Hello, ladies and gentlemen. I'm Bob Toomey, Chief of the North Carolina High-Level Extraction Rescue Team, Western North Carolina Helicopter Rescue Team, and also President and Founder of Tactical and Rescue Associates, who is a group of instructors who have assembled to do our teaching in the field of rescue, fire rescue, EMS, and law enforcement across the state of North Carolina. We have been asked to come up with a training video on ropes and mechanical advantage systems in the field of rescue. And therefore, that is the name of this training video series. We hope that this will be a useful and beneficial training session for you. The thing about mechanical advantage in rescue is it allows you to get so many things done in the field efficiently and safely. Now, along those lines, what we will talk about, what I will go over with you in this training video is the definition of what mechanical advantage is, the advantages of a mechanical advantage system, the dangers of rigging mechanical advantage systems either incorrectly or during sudden catastrophic failures because of the tremendous load that can be put on equipment, ropes, and anchors, and so forth. Now we're going to talk about blocks, block and tackle systems, snatch blocks, the term reeving block and tackles, and then talk about some of the common mechanical advantage systems, such as 1-to-1, 2-to-1, 3-to-1, several different 4-to-1 mechanical advantage systems, 5-to-1 mechanical advantage systems, 6-to-1, and 9-to-1 mechanical advantage systems. I will not go into how to rig anything at this time greater than a 9-to-1 mechanical advantage system, because when you start rigging mechanical advantages that magnify force 9 times, that tends to load equipment and anchors sometimes beyond their rated capacity or their safe working loads, which you're familiar with that term from mountain rescue and rope work in high-level rescue. Safe working loads are critical components. So are safe anchors and some things about anchors. So that's what we will go over in ropes and mechanical advantage systems in rescue. And part 1 will be items 1 through 4. And then part 5, we will talk about part 5, or item number 5 in part 1. But then that will actually become more of part 2 as we move into showing you how to rig mechanical advantage systems. All right, so that's what this is. This is going to be taught utilizing the current standards of NFPA, the North Carolina Department of Insurance, Office of the State Fire Marshal, and things that are taught to the standard of the Emergency Rescue Technician in North Carolina, the ERT program. If you will remember, that was the BRT, and then there was the ART program, Basic Rescue Technician and Advanced Rescue Technician. Those have all been replaced, of course, with the Emergency Rescue Technician program through the Office of the State Fire Marshal. That's what this will be taught to, those standards, today and tomorrow. Now, let's talk about the definition of mechanical advantage. If any one of you were to grasp a rope in your hands and pull upon that rope, that would be a 1-to-1 mechanical advantage, because the 1-to-1 aspect is related to how much you can pull without any kind of assistance other than body muscular activity, your body weight, how much you can hang on to the rope without the rope slipping through your hands, and basically it's what you can pull as an individual, one-to-one mechanical advantage. Now, first, the definition of mechanical advantage is the application of technical rigging to achieve an advantage in a rescue system that will exceed one-to-one. Now, in theory, multiple rescuers on one rope pulling upon a rope is an addition of one-to-one mechanical advantages. If you put 5 people on a rope to pull that rope instead of one person on that rope, you still have a one-to-one mechanical advantage amplified 5 times because you have 5 people pulling one-to-one, as opposed to one person pulling one-to-one. But it is still one-to-one because you have no mechanical devices inserted into the rigging system to amplify all of those 5 people pulling on the rope in such a fashion that it is greater than 5 times one-to-one. In other words, 5 people pulling on the rope is still 5 people pulling one-to-one because there is no interjection of mechanical devices to accomplish greater than one-to-one, whether there's one person pulling on the rope or 10 people pulling on the rope. They're all still pulling one-to-one. So, mechanical advantage by definition is the application of mechanical devices that will aid in amplifying or magnifying the one-to-one pull to where it is amplified 2, 3, 4, 5, 6, 9 or more times to 1. Another way of looking at it also, if I have a weight tied to a rope and I grasp this rope and I pull this rope, for every 1 foot that I pull the rope with my arms or my body, as long as the weight is not too heavy, it moves 1 foot. 1 foot input, 1 foot output on the rope, and 1 foot that the weight moves, one-to-one mechanical advantage. Whereas, for an example, a 3-to-1 mechanical advantage would mean that I pull 3 feet, the weight moves 1 foot, but it moves at 3 times greater mechanical advantage capacity than what I could pull by myself. It will pull 3 times greater than what I could pull. That's another way to look at it. And actually we will have to deal with that when we start talking about mechanical advantage, because a 2-to-1 system, for every 2 feet, the weight moves 1 foot. 3-to-1, 3 feet, 1 foot. 9-to-1, for every 9 feet that I pull on the haul line, the weight moves 1 foot. But it moves under 9 times greater applied force than what I can pull with one-to-one in this fashion. So that's 2 ways to look at the definition of mechanical advantage in rescue. Let's talk about the advantages of a mechanical advantage system in the field of rescue. If you need to lift a heavy object off of an individual, perhaps a piece of farm machinery has fallen on someone, or a piece of a building, or a tree, or a log, or anything, and it weighs more than your body weight, and you tie a rope upon that object and you try to pull it at 1-to-1 and it doesn't move, you do not have the mechanical advantage required to equal and surpass the weight of the object that you're trying to move. Therefore, 1 to 1 may not move it. 2 to 1 may not move it. Even 3 or 4 to 1 may not lift that object off of an individual. You must equal and exceed the weight of the object that you're trying to lift or move by the amplification of mechanical advantage. Therefore, the advantages are you can do the job. You can do the rescue for which you have been dispatched to the scene to do. That is the advantage of mechanical advantage systems. Now, I do want to dispel one idea up front, right off, right now. In some rescue departments and agencies, there is a theory that the old style rigging is no longer valid. That, we have hydraulics and pneumatics, and pneumatic over hydraulic, and mechanical, such that we don't have to rig old-fashioned things, so to say, like pulleys and snatch blocks and block and tackle systems and so forth. Let me just say it like this. The rigging of mechanical advantage will never grow old in rescue. Likewise, it will never become old-fashioned in rescue because not enough people know how to do it. And there are always circumstances and situations such as in building collapse and in confined space, especially with all the environmental disasters that we're having now from floods, earthquakes, other disasters across the country, across the world as far as that goes, terrorism threats, buildings that are destroyed, tons upon tons of debris upon people. And sometimes you simply cannot get hydraulics and pneumatics and air over pneumatics and other mechanical systems into those places for fear of additional structural collapse, or there's not enough room, or the equipment weighs too much. Any number of circumstances can exist in such a fashion that all of the nice machinery that all of us like, that makes our jobs in rescue so much easier, sometimes we simply can't use that. And folks, this is from experience, 28 years now. There will always come a time where this knowledge to rig mechanical advantage systems in confined space, in high level, in building collapse, structural collapse, and numerous other situations will be needed, and it will be needed to be done right, correctly, the first time. Now, as I have said before, some people say, well, which is right? What is the right way? Well, the right way is what is safe. It is what, more times than not, meets NFPA guidelines. It meets Department of Insurance, Fire Rescue Division, Office of State Fire Marshal criteria. But NFPA is a national standard. And to do things to national standards means to do things to time-honored and time-proven methodologies. And again, in rigging mechanical advantage, it's one of those things that's not taught often enough. It's not one of those things that's readily known by rescuers across the state. It needs to be known more, and it needs to be known precisely. Mechanical advantage systems are those things that can catastrophically fail if they're rigged incorrectly sometimes. They are those things that, if they are not rigged correctly, don't work. We're there to help injured people. They expect us to know our knowledge, to know it exact, and to do it correctly. And that's why I am preparing this videotape on Mechanical Advantage, because I want you to know how to do it right, for all the right reasons. So that being the case, we've talked about several examples of what Mechanical Advantage can mean in the fire and rescue field. It's a lifesaver to get jobs done. Rigging gin poles, A-frames, tripods, jib arms, ladder jibs, ladder as a derrick, and any of those things rely upon hand-rigged Mechanical Advantage systems. In this track, we will talk about how to rig the systems. And perhaps in a later video, there may be a request for a video to actually show the rigging and use of these systems that I'm going to show you in part 2. How to apply them to common everyday uses in the rescue field. This is practical, useful knowledge. It's not theoretical. Now, for many years I have studied various authors and topics on Mechanical Advantage systems. The North American Vertical Rope Techniques from the book by Alan Paget and Bruce Smith called On Rope. One of the finest books that you can get on rigging for high level and mountain rescue. Another good example is the Student Guide to Rope Rescue Classes by Tom Vines and Steve Hudson on high angle rescue techniques. One of the finest publications available on how to rig for rescue. Mechanical Advantage systems, rigging, anchors, and ropes, and so forth. Excellent book. George Brown and Gus Christ, who wrote the book on confined space rescue. All types of rigging systems here in very tight confined spaces in order to accomplish a job, where Mechanical Advantage greater than 1-to-1 is required to effect a rescue. Another very good book, and this is just 2 versions of the same book by Dawson Nethercutt. These books right here are the Bible in rigging for rescue, the basics. The International Manual of Basic Rescue Methods by Dawson Nethercutt. Dawson is a retired instructor from the North Carolina Department of Insurance. I was lucky enough to know that man and some other individuals. We have read those books through from cover to cover many times. Those are the Bible on how to do what I'm going to show you in Mechanical Advantage. Those 5 books have what you need to know. There are other good books on the market. I have several others, but those are the main ones that I've used. Mechanical Advantage systems will serve you well if rigged correctly with the proper equipment and good rope, rigged with proper knowledge of application, which a lot of that simply comes from experience. These systems will not fail you, and they will not fail the patient. Quite frankly, they work. They're basic. They're basic, and they go all the way through the most advanced systems. Just like knots. They're used in the most simple system, and they're used in the most complex system, but it's the same knot. And so it is in a way about Mechanical Advantage. Now, let's talk about the dangers of Mechanical Advantage when we come back in just a moment. Let's take a break here for just a minute, and I'll come back and I'll talk with you about dangers of rigging Mechanical Advantage in rescue. All right, now, let's talk about actually dangers that can be associated in rigging in mechanical advantage systems. Mechanical advantage systems are made up of equipment, pulleys, rope, blocks, block and tackle systems, reeving of systems. They're all mechanical. The wear, for example, on rope. Any piece of rope has a safe working load. It has a tensile strength or a breaking capacity that if you do not have that fifth sense feel for when a rope is being stressed too much, things can go wrong. 7/16" diameter static Kernmantle rope has a breaking strength of 7,800 pounds. Some of it has a breaking strength as low as 6,800 pounds, which is the NFPA minimum. In rescue, we use a 15-to-1 safety ratio to account for wear and tear on ropes and equipment, age, use, maintenance, and so forth. You can exceed the tensile strength or the breaking strength of a piece of rope very quickly when you start using 5-to-1, 6-to-1, and 9-to-1 mechanical advantage systems. As with each and every one of you in this room tonight viewing this training tape, you have physical limitations as a human being. This rope, this pulley, and a bunch of the other equipment that I'm going to show you all have physical limits that can be exceeded. Good equipment that meets ASTM standards and specifications, or IFSTA, International Fire Service Training Association, NIOSH, OSHA, and so forth. Any of those standards and all of those standards are important because they rate a piece of equipment for its ability to be able to do work of a specific type. When you exceed those standards that are set for a piece of equipment, it can fail. And when it fails, it's generally catastrophic if it's highly overloaded. One of the reasons, again, that we use the 15-to-1 ratio in ropes and the 10-to-1 safety ratio in webbing applications is to allow for maintenance, age, and wear primarily on rope and webbing and other equipment. Pulling on this rope at 1-to-1, all of you in the room could pull on this rope and probably never come close to the tensile strength of what it would take to break a 7/16" static Kernmantle rope at 6,800 pound breaking strength minimum. But you could get half a dozen people pulling on this rope rigged through a mechanical advantage system and pull it in two. I would not want to be around when the system failed. It would be sudden and catastrophic. We talk about wear on ropes, pulleys, and anchors, and sudden failures, and so forth. We have to talk about that because those things happen. Rarely, but they can and do happen. Rescuers can get hurt or killed. Patients can get hurt or killed. It has to be something done right. And you've heard me say that many times before. If you're going to do it right. There's two ways to rig mechanical advantage. You either rig it right or you rig it wrong. If it doesn't work, it's rigged wrong. And if it's rigged wrong, it's probably unsafe. That's the bottom line. Safety is first and foremost paramount in any rigging system. I don't care what you're rigging it for, or how many patients there are, or who the patients are, or how badly they're hurt. If the rescuers get hurt, you can't help the patients when you're busy getting hurt or killed yourself. A longtime friend of mine used that quote years ago, and it stuck with me. And I use it now too. Wear on ropes. These are designed to be used. They have very high standards. Use them for what they're designed for. Understanding that maintenance is critical, proper use is critical, proper rigging and how they're used is critical so that you do not damage and excessively wear a rope beyond its intended limits. Pulleys. Every time a rope is reeved across this pulley has a pin through the middle of it. There is tension and force that acts upon this pulley, and therefore it acts upon the bearings around this center pin. Equipment, like people, get old. Equipment, like people, need to be maintained. Good maintenance on high-quality stainless steel pulleys like this 1993 pulley it's a Russ Anderson pulley that's used in the high-level mountain rescue classes for Blue Ridge Community College and the Western College. As long as this is taken care of, this is one of the highest quality pulleys that money can buy. Stainless steel, it's the best you can get. Under proper maintenance, it'll last for years. But you overload it, you abuse it, you throw it down on the ground, you drop it, you don't inspect it, and you don't clean it. That becomes a danger of a mechanical advantage system because of the excessive wear on the pulley that it is not designed to withstand, which basically comes from improper use or lack of proper maintenance. Maintenance is critical, folks. Good equipment won't let you down, but equipment thrown away dirty, equipment not maintained and cleaned, equipment not properly inspected by people who know what they're looking for in equipment can get people hurt. That pulley can have thousands of pounds of weight put upon it. The minimum strength of that pulley is 10,000 pounds, 5 tons. But the pulley won't ever be loaded that much because it's designed for a maximum 1/2 inch diameter rope. And if you put that kind of weight or tension or stress upon a rope, the pulley will function properly, but you will have stressed the rope beyond any safe use. If you will remember, when I would talk about the NFPA ruling that said one use, emergency lifeline use of a rescue rope, according to NFPA guidelines, requires that rope be discarded. Well, I don't know very many people in the state of North Carolina that do that because they don't have the money to do it. It's nice to know that that's what it takes to have proper equipment, but every time you go out on a high-level rescue, are you going to have new equipment each time to do it? Likely not. Equipment's too expensive, but if it is properly taken care of and used and stored correctly, then it's not a problem. Anchors. I cannot say enough about having what's known in the mountain rescue and high angle terminology field, bomb-proof anchors. Anchors that fail when they have several thousand pounds of weight exerted against them, either pulling against them or pushing against them, however you're using your anchor. if that anchor fails, the best rigged system in the world will not make any difference because it can't. If its anchor, if the foundation of the best system you rig fails, then the system is useless. Anchors that fail, posts, beams, railings, trees, that you're depending upon the root system of the tree or the strength of the diameter of a tree if you're rigging for a high-level rescue. Any example like that, any kind of an anchor. The anchor that you use in the change of direction on the upper part of Rescue 32, when you're doing a scree-evac, pulling up a patient and several rescuers up a bank. The weakest link of the system is the strongest of the system when you look at all of the links together. If the weakest link fails, then the best of the systems fail. Ladies and gentlemen, anchors are critical. Anchors have to be chosen for their intended purpose and for their expected use, and they have to function properly in that use. For the finest system that you rig, makes no matter. Let's talk about ropes, cables, and chains in mechanical advantage systems, briefly. Of the three, a cable will store energy in a far more dangerous method than a rope or a chain, and there's a reason for that. A standard cable, for example, a wrecker cable, the cables that you have on your rescue trucks, are twisted or right-laid cables. All cables are made that way, at least all cables in rescue that are common, are right-laid 3 or 4 strand cables. The ones you have at Brevard Rescue are 3-strand laid cables, laid to the right. A cable being longitudinal strands of steel that are woven together into 3 laid strands together will store a tremendous amount of energy. They will recoil more readily at the speed of light and like a laser. And if a cable that perhaps is being used to pull a car up an embankment, can you imagine a 1/2-inch diameter cable that might have 6 or 8 or 10 tons or more of force on it, and you stand beside that cable and it breaks and it whips around, what it can do to a human body and all the turnout gear in the world on your body won't make a hill of beans difference. If that cable snaps like that and cuts back across your body, you will be picking your turnips from a stepladder. It's all over so fast you won't know what hit you. It will kill you dead, if not seriously injured. Some cables, depending upon how old they are and how they've been used and how kinked and stretched they've been and so forth, some cables will recoil in a straight line, some will whip back 180 degrees all the way back behind you, either sideways or up over the top. Can you imagine a 1/2-inch diameter cable coming straight back and splitting your fire helmet and your head all the way down to about the middle of your shoulders or your chest? Just like somebody took an axe and just cut right through the top of your head. That's how dangerous this stuff is. That's how real this stuff is. Cables fail catastrophically. In training, you have probably seen numerous times where we would put blankets, turnout coats, tarps, or pieces of carpet over a tension cable so that should that cable fail, those act as a dampening agent to absorb the tremendous tonnage of impact instantly released upon the breakage of that cable. Those devices help dampen the stored energy in that cable very quickly. But they do not prevent the storage of energy. Ropes, on the other hand, if it's a laid rope, will break in the same fashion, or if it's a static kern mantle rope like this, can still fail. Normally ropes fail and recoil in a straight line, especially kern mantle ropes that have fibers of nylon that are parallel to each other inside this mantle or covering. When they break, the rope tends to break in a straight line, but not always. But if the breaking strength of this piece of blue water tube, 7/16" diameter static kern mantle rope is 6,800 pounds, and I break this rope at greater than 6,800 pounds, such as, say I have 7,400 or 8,400 pounds on this, that's over 4 tons of tension on this rope. I ask you, do you want to be around it if it fails? I sure don't. I don't want to be anywhere near it if it fails. But a cable is worse than a rope. But a rope that is a laid rope, like your Poly Plus ropes, the white ropes with the red strands. The Poly Plus rope is a laid rope, and it can break in a straight line, or it can whip back around like a cable because of the laid technology of the strands and the fibers of the rope. Chains, on the other hand, if chains fail, they're kind of like a self-dampening system, and I think you can see why. If a chain fails, each link is an independent component of that chain. Stretched tightly, all of the links are against each other end to end. But if one end of the chain should fail, and the chain begins to collapse or recoil upon itself, then the stored energy of that chain is transferred along the length of the chain for however many hundred of links you may have in that specific length of chain, and each link helps to dampen and absorb the recoil of a catastrophic failure of a chain that's been overloaded. And let's face it, folks, when you overload a chain, you've got quite a few tons of force on it. When you overload a cable, you have many tons of force on that. If you overload a rope in a rigging system, you rig too much mechanical advantage to do the job, and something else was needed, or a different configuration, or a larger diameter rope, or whatever. Cables are the worst if they break. Ropes are next, and chains generally are third. But just as sure as I say that, you will see a chain break that recoils straight back through the radiator of a truck. I saw that happen on a farm truck one time when I was on a farm. A tractor was pulling a farm truck out of a mud hole where they had gotten stuck, and they pulled so tightly on the chain that the chain, and I'm talking about half-inch diameter, large steel-linked chain, when it broke, it recoiled so straight back towards the front bumper of that farm truck that it went through the grill and straight through the radiator into the fan. Devastating, instantaneous fracture, just like that. Thank God nobody was standing by. The man on the backhoe watched the chain come hit straight at the base of the boom on the backhoe. And luckily it did not come around and go straight through his head where he sat upon the seat of the backhoe. Things happen, folks. Overload people, they can't perform the job. Overload equipment, the equipment fails. It's the same difference. Maybe now you begin to see what I talk about when I say that rescue is a combination of what's in here and that knowledge that you can use in your hands and go to the field and effect a job safely. All of the Mechanical Advantage systems, everything that you will do in rescue is an extension of your knowledge and your ability to make your hands rig what is necessary to extend work beyond your fingertips. That is rescue. And that is also Mechanical Advantage in rescue, the same thing. All right, so we've talked about the definition of Mechanical Advantage, the advantages of Mechanical Advantage systems over straight hand systems, the dangers of Mechanical Advantage systems, what happens with the wear on ropes and pulleys and components and anchors that are not solid enough to hold what needs to be held, sudden catastrophic failures, failures of cable, rope, and chain. Now what I want to move into is to show you several different snatch blocks, block systems, and blocking tackles. And then we will move into part 2 of this training video on ropes and Mechanical Advantage in rescue, where I actually show you how to rig Mechanical Advantage systems. I will ask you to bear with me as I will have to go back and forth to the camera at different times as I show you certain components. Right now there's just one of me to do this training video, but I will try to make it as smooth in transition as possible. It's about the best I can do. We will take a short break. I will come back and go through item 4, and then we will go to item 5 on rigging Mechanical Advantage systems. Thank you.